In this video, we shall see how to do the computer drafting of the orthographic projection of lines using the Solid Edge software. Looking at the problem statement, a line has its end A 10 mm above HP and 15 mm in front of VP. The end B is 55 mm above HP and the line is inclined at 30 degrees and to HP and 35 degrees to VP. Draw the projections of the line, determine the true and the apparent length of the line and its inclinations. So if you look at the problem statement, we can arrive at a set of conclusions. The first conclusion is the details about one of its endpoint A is given, that is 10 mm above HP and 15 mm in front of VP. Also, regarding the second endpoint B, only one detail is given, that is it is 55 mm above HP, but they have not told whether it is on VP or how much distance it is in front of VP. But however, the only data that is available with us is it is 55 mm above HP. And next is the true inclination is given, that is it is inclined to HP at an angle of 30 degrees and to VP at an angle of 35 degrees. So with this data, we need to draw the projections of the line and also determine its true and the apparent length and also the inclinations. So the true inclinations are given to us. We need to find out the apparent inclinations. So we shall see how to solve the problem. So we will begin with drawing the XY line of thickness 0.18 mm. So we'll draw the XY line of any arbitrary length and annotate the line as X and Y. The reference planes above the reference line is VP and that below the reference line is HP. So now we shall locate the endpoint A, which is 10 mm above HP and also 15 mm in front of VP. These are the projector lines and they shall have a thickness of 0.13. So you can select the line and change the thickness to 0.13. So now we will draw the locus of this particular endpoint A. So to draw the locus line, select the dotted line of thickness 0.13 and draw the locus of A in both the reference planes. So we will annotate the front view of the point A as A dash and the top view of the point A as small a. And this line is the locus of A in the vertical plane and this line is locus of A in the horizontal plane. So now this data is done. So now he tells that the line is 30 degrees inclined to HP. So we will see to that. And before that, the data that is available to us is the endpoint B is 55 mm above HP. So first we will try to draw the reference of the point B, which is 55 mm above HP. So, but we do not know what is the distance between A and B. So we will assume any particular distance and we'll simply locate the point B in space, which is at a distance of 55 mm above HP. So we can understand that the locus of this point B line will be at a distance of 55 mm above HP. Or we can also do this, that is, instead of drawing a line like this, what we can do is we can select the locus line and then try to offset this locus line upwards at a distance of 55 mm from the HP. So we'll select this line and then we'll tell offset. .55, so it is asking the distance. So this is the direction in which the offset has to be done. So this is at a distance of 55 mm. Okay, so we need to offset the reference line. So we will just edit this to 45 because here it is 10 and this is 15. So if I edit this, then I guess it will be 45. So what I can do is I can select the offset option, select the line that has to be offset and enter the distance as 45. It has to be in the upward direction. So now select the distance between these two lines. So you can see that it is the distance of 55 mm. Okay, so this is the locus of B. So we'll annotate this line also. So this line is locus of the point B in the vertical plane. So now we'll complete the line. So we will take this. So he tells that this particular line is at a distance, at an inclination of 30 degrees to HP. So I'll have to fix the inclination at 30 degrees and try to extend the line until it is meeting the locus of B. So this is the true length of the line. So if you just measure this true length, I'm going to get the solution as 90 mm. So 90 mm is the true length of the line. So let me annotate this point as B1 dash. Okay. So now we do not know what is the distance or where is the locus of this particular point B in the horizontal plane. So what we will do is we'll follow the procedure to draw the top view of this line, that is A dash B1 dash. So what we will do is we'll select the line option. We will select this and then we will try to make this line parallel and it is intersecting here. So this point is AB1, which is the top view of the line A dash B1 dash. So now keeping the point as A and the length of the arc as AB1, I'll just cut a arc like this. So somewhere here, wherever on this arc itself, I'll be having the position of the point B in the top view. So now I also know one more data, that is this particular true length of the line is inclined at an angle of 35 degrees to VP. So keeping this in mind, so from the point A, let me draw a line of length 90 mm and the angle of inclination is minus 35. So here this is minus 35. So you can just measure this. So this angle is 30 degrees and this angle is 35 degrees. So theta and phi is measured. So somewhere here only I'll be having the locus of line B. So I'll select this line option, draw the locus of the point B from the end point of this line. So here this is B2. So now I can draw the true length of the line in the horizontal plane. So I'll select the line continuous line option and thickness is 0.50. So from the end point A to the point of intersection of this locus line and the point B, I'll be drawing this true length of the line in the horizontal plane. So we can just measure the true length, which is 77.94, and this is the true length, which is equal to 90. Correct. So now this point is AB, which is the top view of the line AB in the horizontal plane. So now we will have to record the front view of this line, that is A dash B dash. So for that, what is the procedure? So the procedure will be, I'll select the line option again. So from here, from the end point of this line, I'll have to draw a line perpendicular until it is intersecting the locus of A. So this point is going to mark the front view of the point B2. So this is B2 dash. And then I'll be selecting the arc by center point, keeping A dash as the center and the radius of the arc as A dash B2 dash. I'll be drawing a line until it is intersecting the locus of B. So the point of intersection of this locus of B and this arc is where I get the end point of the true length of the line. So it should be a continuous line of thickness 0.50. So from A dash, so here this is the true length of the line in the front view. So I can measure the true length, which is 73.72 mm, and also the values of alpha and beta, which is 38 degrees and 41 degrees respectively. Okay, so with this we can just verify the problem. So let me select the line option and select a projector line of thickness 0.13. So the endpoint of this is meeting with the endpoint of this, so which indicates that the projections are correct. So you can just show this as the continuous line, that is the top and the front views of this rotated lines. So point V1 is here. So we have completed the problem. So to just revise, it is 10 mm above HP and 15 mm in front of VP. So this data is given to us, and also the data of the endpoint B is given. So that first we have to indicate the locus of the point B in the vertical plane, and then complete drawing the true length of the line. And after this, we need to uh, draw the true length in the horizontal plane with the angle of inclination that is given to us, that is 35 degrees to VP. So here the key point is the true length is going to measure the same in both VP and HP. So keeping this concept in mind, we need to draw the true length of the line. So we have answered the question. So the true and the apparent length is already measured. The true length is 90 mm and the apparent lengths are 73.72 in the vertical plane and 77.94 in the horizontal plane, and the values of alpha and beta are 38 degrees and 41 degrees respectively. So with this we complete the problem.